Okay, let's do chapter 15, and chapter 15 is about multiple regression. Okay, the difference between simple regression and multiple regression is basically that instead of having one independent variable and one dependent variable, you are going to have multiple independent variables that are going to really affect my dependent variable. This is again my y, and this is x1, x2, x3, and so on. Basically, the model, instead of having 1x, it's going to be y is equal to beta 0 plus beta 1, x1 plus beta 2, x2 plus whatever, plus an epsilon, and again, epsilon is a random variable, normally distributed, and the expected value of this epsilon has to be equal to 0. Okay? This is the model. The regression equation is going to be what? The expected value of y is going to be equal to beta 0 plus beta 1, x1 plus beta 2, x2 plus whatever, beta whatever. And of course, we are going to estimate the regression equation, the estimation of the regression equation by using the data points. Is going to be y is equal to b0 plus b1 x1 plus b2 x2 plus the number of independent variables that you have. Remember that when we talk about simple regression, we talk about b1 is the slope. Okay, when you are dealing with more than two variables, more than two independent variables, it's practically impossible to draw or to try to imagine these relationships. Now, these numbers, the b1, b2, and b4, are the interpretation of nothing but how much is going to change my dependent variable if I increase 1 unit of my particular independent variable. So let's say that I have y is equal to 3 plus 5x1 plus 7x2. What it means? This 5 tells me that for every unit that I increase in xy, 5 will be increased in my y. This 7 over here indicates that by every unit that I increase my x2, y will increase 7 units. And the same thing happens if you have, for example, y is equal to 3 minus 7x1 minus 3x2. Okay? This negative 7 is what my dependent variable is going to decrease every time that I increase 1 unit my x1. The same thing happened with the minus 3. So basically that's the interpretation of these parameters, my b's. And the same thing happened in simple linear regression. The b0, the b1 is exactly the slope, but the slope tells you how much would be changing my dependent variable every time that I change my independent variable by 1 unit. So this is it. Multiple regression is nothing but the simple regression, but with more than one independent variable. And it's again linear regression because my x are really x1, x2. They are not x1 squared or x1 cubic or something like that. So the exponential of all my variables are 1. Now, I mean, this chapter is pretty easy, I guess. Once you know the simple regression, multiple regression is nothing complicated at all. The R squared is the same thing that was in simple regression. The R squared is the proportion of the variance. Proportion of the variance of the dependent variable that is explained by the variance of all the independent variables. Okay? So really, R squared is the proportion of the variance that is explained by all the independent variables. Now, how do you test your regression? Well, you use the F, and again, regression analysis is going to give you the ANOVA table, and ANOVA table will give you the F that is equal to MSR divided by MSE, mean square of the regression divided by mean square of the error. And what is my hypothesis? My hypothesis is going to say that B1 is equal to B2 is equal to B3 is equal to whatever is equal to 0. So that there are no regression, there are no relationship between the independent and with all the independent variables. Against my alternative hypothesis that not all B's are 0. And again, what we want to have at the end is reject the null hypothesis and saying that there is a strong regression among or between the dependent variable and all the independent variables. That's it. That's what you need to know, really. Okay. Let me explain you something that might affect the results of your regression in multiple regression. It is called multicollinearity. Multicollinearity is a condition that happens when there is a strong correlation between the independent variables. The objective on regression analysis is to have all the independent variables very correlated with the dependent variable. However, you don't want the independent variables to be correlated with each other. Why? Because when you have two independent variables that are highly correlated, it may be that at the end you may have confounding effects on the variables that are highly correlated. And these problems is what is called multicollinearity. And you can solve that by running correlation analysis for all the variables. And if you see two variables that are highly correlated and the rule of thumb is probably 0.6 or 0.7, you should not have independent variables that are highly correlated. 0.6 or 0.7 are too high. So you need to eliminate at least one of them. Okay. Another important aspect in regression analysis is how do you handle categorical variables. Okay? So let's say that you have a categorical variable that probably gender, male and female, right? How do you include male, female in a formula, in a linear formula? You cannot do that. So you have to use what is called dummy variables. That this variable is going to have either 0 or 1 as the value of this dummy variable, and the number of dummy variables that you need is the number of categories for your variable minus 1. In this case, you have 2 categories, so you are going to need just 1 independent dummy variable, and the value of these are 0 and 1, and probably this is females and this is male. So then you can use the 0 and the 1 in a formula with no problem. If you have, for example, 3 categories in your categorical variable, you are going to need at least 2 dummy variables, okay? But that's the way you handle categorical variables in regression analysis. That's it. I'm not going to ask you to do anything more than that. Another thing is, back in the chapter of your book, and it's called logistic regression. Okay, logistic regression is used when your dependent variable, your y, can only take 2 values, probably 0 and 1. And this regression, logistic regression is very used, especially when you are dealing with approve, not approve kind of thing. And for example, when you apply to a university, they should have some formula, okay, that tells you whether you are likely to succeed in that university. They use probably your GPA, the SAT scores, probably how far do you live from campus, age, whatever. I mean, I don't know really what is the formula that the universities use in order for you to be accepted or rejected. The same thing happens